Okay, this is my first video for grade 9. Already I published nearly 30 videos for grade 10, grade 11 as well as advanced or combined maths. So here I take one lesson to explain fully for a grade 9 type chapter. I take that indices, right? So put the heading indices. Write the heading indices. So they all are newcomers for grade 9. So please subscribe this my video and press the bell sign. You will receive automatically all the grade 9 type videos hereafter. Also you can find if you have any brothers, sisters or relations, you can see my grade 10, grade 11 videos and also advanced or combined maths videos. So we'll see one chapter called indices. So basically in the grade 6, the beginning of the indices available. What is indices mean? Bases and powers involving, for example, x multiple x. You called in the previous past grades answer x square. Answer is x square. X multiple x, answer is x square. So a into a into a into a like this, a to the power 3. Like here the base and power involving we call the indices or index form. Here x is the base, 2 is the index, complete the index form, 2 is the indices. Okay, here we have so many major parts of indices. There are some rules of indices. You can't simplify the indices what our wish. There's a rule we have to follow when simplifying the questions of indices. That's showing them more in the grade 9 type problem. You can see in the grade 9 that is chapter 12 in your part 2 book. Part 2 book chapter number 12. I will show all solutions of answering these problems. And before that there are some rules of logarithm, the indices, right? So write the heading rules of indices. Rules of indices. So see what are the rules. We have so many rules in indices. Step by step we'll see rule number 1 first. So rule number 1. So what the rule number 1 state that a to the power m multiple a to the power n, a to the power m multiple a to the power n. That means if the bases are same, right? If these both are same, when you multiple at the power, so the answer a to the power m plus n. This is rule number 1 of indices, right? Bases are same when multiple at the power. Copy this. With me you work, right? If any problem, pause the video and check your work and verify, clear it. I'll show an example of this. Example 1. X square multiple x to the power 5. X square multiple x to the power 5. So what is the answer? These both are same, multiplying, therefore at the power. So answer x to the power 2 plus 5, 7. 2 plus 5, 7. This is the application how to use the rule number 1. Bases are same, multiple when at the power. See another example. 2 square, 2 to the power 3, 2 to the power 4. So what is the answer? Not only two number, any numbers can be multiple, any values can be multiple. So bases are same, all these multiple at the power. So what is that? 2 to the power at that 2 plus 3 plus 7, that is 9. 2 to the power 9, right? Is the rule and few examples along this. Next write rule number 2. Rule number 2 of indices, rule number 2, that is state like this: a to the power m divide a to the power n. Dividing rule. If the bases are same, when divide, subtract the power, right? This divide I can write like this also. A to the power m over a to the power n. It also same meaning, dividing symbol, or write a fraction. That also same meaning, right? Therefore, but the answer, bases are same. So subtract the power, m subtract n, that is m minus n. Rule number 2 of indices, bases are equal when divide, subtract the power. I'll show a few examples. Example 1, x to the power 10 divide by x to the power 4. X to the power 10 divide by x to the power 4. So what is the answer? Bases are same, dividing, subtract the power. X to the power 10 minus 4, or that is what? 6. Not 6, x to the power 6, right? See another example. Y to the power 12 divide y to the power minus 5. Follow same method. Y to the power 12 divide y to the power minus 5. So follow the rule, second rule of indices. Bases are same, dividing, subtract the power. Therefore, y to the power, what is that? 12 subtract minus 5, right? 12 subtract minus 5. Okay, so what is that? Y to the power 12 minus multiple plus 5. So answer y to the power 17. Y to the power 17. This is the rule number 2 of indices, right? Right, next, rule number 3. Third rule of indices is like this. A to the power minus m. A to the power minus number. There's a minus power. In mathematics, we won't write the minus power. If it comes so, how to remove the minus? That's we are studying this rule, right? That is 1 over a to the power m. If minus comes, right, it's reciprocal. If it's come minus up, right below here, no minus, reciprocal. If it's come minus below, right up. Okay, see example. X to the power minus 5. X to the power minus 5. So what is the answer? Remove the negative power. What is that? 1 over x to the power 5. No minus change to positive, right? Another example. One example. Another example. If it's 1 over 3 to the power minus 10. 3 to the power minus 10. The question comes, show the value as a positive index, positive indices form. So you take up. So the answer 3 to the power 10. Later we show more problems. Now only few examples for each rules. So that's the answer. This is rule number 3, right? Next try rule number 4. Rule number 4 of indices. That is state like this. A to the power 0. A to the power 0. What is the answer? That means any power 0, any index 0, answer is 1. Answer is 1, right? Any number power is 0, answer is 1. Simple. Yeah, for example, 7 to the power 0, 1 over 10 power 0, minus 22 power 0. All what? Answer is 1. Here 1, here answer is 1, answer is 1. Any degree power 0, any number power 0, answer is 1, right? Let's try rule number 5. Rule number 5 of indices, that is state that like this: a to the power m completely power n, a to the power m completely power n. What is the answer? This we call, I say like this, I pronounce like this: power of a power, power of a power, right? Therefore the answer is, you multiply these two powers, that is a to the power m multiple n, multiple the two powers. So that is a to the power mn, a to the power mn, right? Power of a power rule, multiple the both power. See example, x power 6 totally power 2. Alright, what the answer? Y to the power 5 totally power 3. Right, what the answer? A to the power 10 completely power half. See what are the answers of this using the power of a power rule. That is what here, x to the power of a power 12 multiple 6 times 2 12, and here y to the power 15. Here what, a to the power 10 and multiple half. What is 10 multiple half? What is 2? 5, right? 5. Okay, these are the 5 rules frequently using in these grade 10, grade 9 type questions, right? Okay, now we see some problem. I will show you all the questions from your grade 9 part 2. This is chapter 12, right? So we'll work one by one. I show you the problems in page 24. Page 24, the simple, they shown the book separate types. Rule number 1, separate exercise. Rule number 2, separate exercise like this. All rule for up to 5, they shown exercise problems. So I take this to work rule number 1 type questions. First type, first one, 2 to the power 5 multiple 2 square. 2 to the power 5 multiple 2 square. They has to fill the blanks. So I show completely what the answer. You decide what the proper value or values inside that blank. So what the answer? See the rule number 1. Bases are same when multiple at the power. So 2 to the power 5 plus 2. Otherwise 2 to the power 7, right? Next question, x to the power 4 multiple x square. X to the power 4 multiple x square. Use the rule number 1 and find the answer. So bases are same, only we can use the rule. Rule can be applicable. So x to the power at the power 4 plus 2, 6. So next one, a cube, a to the power 3 multiple a to the power 4 and multiple a. So how that calculation? Bases are same when multiple at the power. Your power is 1. No, a means power is 1, right? So what the answer? A to the power 3 plus 4 plus 1. That is a to the power 8. A to the power 8. Next, there question number 4. 5p power 3 into 3p. 5p cube multiple 3p, what the answer? So here there's a two numbers 5 and 3. That is, you multiple, ordinary method you multiple. So 5 times 3, 15. No doubt 5 multiple 3 is 15. And what? P to the power 3 multiple p. Okay, first you multiple the numbers separately and show that p to the power 3 and p. So what the answer? 15. Here show rule number 1. Bases are same when multiple at the power. Here 1, so p to the power 3 and 1, 4. They asked to fill the blanks. You should follow my method and you can complete the full answer there. Next one, fifth one, x square multiple y cube multiple x to the power 5 multiple y to the power 5. Simplify this. Not only one term, any number of term can be multiple as a powers. You can use the rule number 1 of indices. So here I will rearrange totally x is how and the y is how. So x square multiple x to the power 5 and write the y separately into y to the power 3 multiple what? Y power 5. Okay, now follow the rule number 1. So bases are same, multiple at the power x to the power 7, 2 plus 5, 7, and multiple y to the power 8. So whatever number you can add and show, simple rule. Grade 9, very easy. So keep in touch, come continuously in grade 10, grade 11, a year after advanced maths also. You're using the indices works. This type 1 they shown there. The next question, the two blanks given, column A and column B, you link it. Column A and the column B, next one. Some practice question how to use this rule number 1 for indices here. X to the power 7, x to the power 8, x to the power 9, 10. So for the problem how to use the rule number 1. The bases are same when you multiple at the power, that rule. So follow that. So what the answer here? X cube multiple x to the power 7. Bases are same when multiple at the power 3 and 7 is 10. Therefore x to the power 10. Okay, here see bases are same, multiplication at the power 5 plus 2, here 1 If only the base power is 1, don't say 0. Here 1. So 5, 7, 1, that's 8. Here 8. Here also 1, that also 8. Here what? 8, 10, this is 10. Here what? 5, 7, 8. So simple thing, therefore I think the power 8 belongs to 3 answers. So here we use another type, the way of answering bases are same, add the power and connect the answer from the column A to the column B. Next we go to the question number 3 type, third type problem. Say your bookwork or you write this, simplify and find the value. Simplify and find the value. First question, 3 to the power 5. Again that 3 to the power 5. Now first to complete this problem. The two parts they are, first to simplify and find the value, right? So what is simplifying here? Bases are same. If the bases are same, multiple at the power. So 3 to the power 5 and 5, 10. 3 to the power 10, they mention the big value. And find the value. Now what do you mean find the value? You multiple 3 10 times. 3 into 3 into 3 into 3 10 times and write the answer. 3 times 3 9. 9 times 3 27. 27 times 3 81. 81 times 3 243. Like multiple become very big number and write the answer, right? That's the meaning of this question, not only indices but also find the final value. Next one, 7 square multiple 7 to the power 3 multiple 7. Using the simplify and find the value. Simplify and find the value. So bases are equal when you multiple at the power. 7 to the power 2, 3, 5, here 1, 6. And write the answer. What is 7 to the power 6? 7 multiple 7 multiple 7. Like multiple 6 times and without error get the accurate value. 7 times 7, 49. 49 times 7, 243, like that. And multiply everything and get the answer of 7 to the power 6. Not only just find the answer also. So I hope you can calculate by multiple 7 6 times, write the value. Okay, next question, type 4, simplify. Question 4, write the problem, say your book, simplify. First question, x to the power 3 into x to the power 6. So once again, same repeats. They shown type rule number 1, separate problem. So what the answer? Bases are same, multiple at the power. X to the power 9. Second question, x square multiple x square multiple x square. So what is that? X bases same. Then only we have the rule. At this power 2 plus 2 plus 2, 6. Third question. All the bases are equal to A, all multiplication. So at the power. So e to the power 3 plus 2, 5. 5 plus 4, 9. a to the power 9. See how this question, 2x cube multiple x to the power 5. So there's a number also, 2 only, that is separate, so write 2. And here use the indices, base the same, multiple at the power, 3 plus 5, 8, x to the power 8. Same, next one, 5p to the power 3, 5p square power 2, 2p power 3. So if a numbers come, multiple numbers separately and write the indices by adding the powers. So the answer, 5 times 2, 10, p to the power 2 plus 3, 5. All these multiple. You also multiple the number separately. First, what? 4 times 2, 8. 8 times 3, 24. And write the other x power is what? All bases are same. So your power is 2, your power is 1. Here don't say 0. If only a base power is 1. Here 5. So all addition 8. X to the power 8, 24 x to the power 8. Our next question, you can try this your own, try and see what the answer. So any problem, stop the video, recheck. With me you work, with me, with my explanation you also work, right? That's the way of studying is online teaching. I publish many videos for the other grades. The first time I'm showing the grade 9. Please subscribe and press the bell sign. You'll automatically receive so many videos thereafter. I try to implement through the YouTube channel. Here what? 2 there, 2 separately. And I write the m separate and n separate, m square and here a m. Now write the n separately, n square and here a n, right? So what is that? 2 m square multiplied by m, bases same at the power, here 1, so m to the power 3, the same answer, n to the power 3. Next problem 7, problem 8, so 7th question, 7th problem. 2a power 2 multiple 3b square simplify using all the indices. Rule number 1, still we are processing the rule number 1. So like this question, first you multiply the number separately and a separate, b separate. So what the number value here? 2 times 3, 6. 6 times 5, 30 times 2, 60. Number is 60. Then what? A square and here a and here b square and b to the power 3. B to the power 3. So what is that? 60 What the answer? A square multiplied by A means what? A to the power 3. Here B to the power 5. The bases are equal when multiple, add the power and write it. That's the rule number 1 says. Okay, next what the question number 5. Problem number 5. A pair of positive integral values of m and n can be taken so that the equations, see they said there's an equation x to the power m multiple x to the power n equal x to the power 5. Holds true is 3 and 5. Write all such pairs of integral values. Here 8. Yes. So what did we go through and see the question number 5? They are given indices equations x to the power m multiple x to the power n equal to x to the power 8. So they said here m and n are positive numbers, integer value. What is positive? Therefore you can't take the minus value. What is integer? Mean whole number, real integer, full whole number. You can't take decimal, you can't take fraction. One pair they given. What are the m value possible? Here 5, here 3, because bases are same at the power. So we find some other pairs. So here x to the power m plus n, bases are same at the power. This is equal to x to the power 8. Okay, therefore m plus n equal to 8. No? Bases are same at the power. Therefore m plus n equal to 8. Then you think two values. What is m? What is n? They given m is 5, n is 3. M is 5, n is 3. So you think other they ask how many values? Write all such pair of values. You can write many values. So that if m is 6, n is 2, 6 and 2, 8. M is 4. Or maybe n also 4. 4 and 4, 8. So not only that, sometimes they say m and n are not equal numbers to different number, then you can't take 4. Same number, if they say m and n are two different values, then you can't take the both equal. Different answer. So here I take both are same. And what if m is 7, n is 1. 7 plus 1 is 8. There's a positive value. If you say m is 8, n is 0, you can't take n 0 because both are positive. 0 is what? No positive, no negative. Let's see if m is 5, n is 3. That's they said, right? Then you put m6, 4, 4, 7, m8 you can't take. So these are the three pair of values. Or if m is 1, n is 7. This comes alternately. Same number repeats. M1, N7, M2, N6, M3, N5, M4, N4, M5, N3. There you can take all the values. That's the idea of this such problem, right? Okay, this I use to complete the rule number 1. So refer it, keep in touch, and go through the other exercise using the division rule of indices. Bases are same. When dividing, subtract the power. You work that. The second other video, I will show brief solutions for that. So keep in touch with me with pressing the subscribe sign and the bell symbol. Automatically you will receive. Also forward these videos your friends, classmates, schoolmates and other friends or other relations, then you will credit all my successfully fully solving well explanation videos for grade 9. Already I published many videos, nearly 30, more than 30 videos for grade 10, grade 11 and A-level combined maths.